Good afternoon, everybody, and thank you for joining today's webinar. My name is Cheryl Jennison DeProsa, and I am joined by Mr. Chris Lyons and Mr. Gino Sigismondi. And today we're going to be going through some audio basics for the IT professional. Before we dive into that, however, we have a couple of notes of housekeeping. First of all, this webinar is being recorded, and it will be available in our webinar archives sometime within the next week or two. You can go to shure.com/training to view all of our webinar archives. We've got a lot of great webinars across a lot of different topics. So feel free to go over there and peruse, not just for this one when it's available in a couple of weeks, but all of our other great past educational webinar series. The second item to talk about is that if you have any questions, please feel free to type those into the question pane. We will be answering as many questions as we can get to within the hour at the end of the session. So please type in those questions and be patient. If you don't see a question pane, just look for a small gray toolbar that has an orange box with a white arrow on it. Click on that, and that will maximize the toolbar to give you access to the question pane. So as I said, we'll answer as many of those as we can at the end of the session. That wraps up all the boring stuff. Let's get into the good stuff. Take it away, Gino and Chris.
Thanks, Cheryl. Welcome, Gino.
Thank you.
It often seems like audio people and IT people were raised in different hemispheres and don't speak the same language. So today we're going to kind of go into audio as if we're talking to IT people who have backgrounds in everything IT, but not necessarily audio. And we'll talk about some of the things that are similar and different, and have some good tips for getting better audio in the meeting environment. So we'll talk about a little bit about the purpose and the parts of a sound system, a little bit about microphones. We'll dive pretty deep into digital audio networking, and then we'll talk about just some of the major applications here too. So first of all, the purpose of a sound system, it comes down to three things. Number one, audibility. You want everybody to say that they can hear you. And of course, then intelligibility is once they can hear you, can they actually understand you well? And then finally, fidelity is where we get into the quality aspect of it. Does it sound good or does it sound annoying or fatiguing? We've all been in meetings where the sound is so irritating that we cannot wait to get out of there and for that call to end. And we want to get away from that. So hopefully at the end of this webinar, you'll know some things you can try to get into that fidelity category. The sound system really can be divided into sort of three parts or three sections. You've got the sound source, which in our case is usually a person talking, and then the room itself, which they're in, that plays a big part. And that's where we're dealing with acoustic energy, which is just variations in air pressure. Then once we get to the microphone, now we're converting the acoustic signal into an electrical signal, which goes through some audio processing and mixing, then onto an amplifier and a loudspeaker. And at that point, it's just variations in voltage, whether it's analog or digital. Then after the loudspeaker, we're back into the acoustic domain where the sound travels through the room. So the room gets another cut at influencing the sound before it reaches the listener. So we go acoustic, electrical, and acoustic. And we'll talk a little bit more in detail about each one of these steps along the way here. First of all, let's talk about microphones, just so we have sort of a basic ground plane here. And there's three basic essential things you got to know about microphones, where they differ from each other, that are relevant to meeting rooms. There are some other factors that are more relevant to recording studios or music, but we're not going to cover those here. When it comes to meetings and conferencing, we're looking at physical design, directionality, and electrical output. So let's talk about each one of those here. First, physical design is what we all think of as the shape of the mic, what it's designed to do, how you wear it or hold it or whatever. The trusty old handheld mic is still really popular, makes a great question and answer mic, and is sort of the do-it-all workhorse. Then there are microphones that mount or attach to the user themselves. So you might have the lavalier microphone on the upper photo there, or a head-worn or ear-set microphone on the lower photo. And those are designed for an individual person. You can't mic a group with them, really. But the big advantage is that it goes where the person goes. So if you've got a presenter moving around, that is an excellent way for the audio to stay consistent with that person as they move around. And we should note that the ear set really has the advantage there because the ear set is even closer to the talker's mouth than the lavalier mic is. So in somewhat dicey situations maybe, where the noise is a little bit higher or you're worried with higher loudspeaker levels, worried about feedback, the earset mic definitely has the advantage.
And I'll just add in there too that not only is there the advantage of it being so close to your mouth, but it also, in terms of the consistency of the sound, is the best option as well. Because even with a lavalier mic, though it is attached to the presenter itself and moves with the presenter, if the presenter moves her head like you see in the photo there, right, to side, a lot of movement there, you can still get inconsistencies in level and sound quality as the head moves back and forth. Whereas the boundary, the head worn microphone is right there with your mouth, even when you turn your head. So it really is the most consistent direct sound quality you can get. So out of those three options there for miking an individual, right, the handheld is probably the most universally known microphone when people see a microphone, but it also requires you to have some idea of what you're doing, which is holding the microphone pointed at your mouth and not holding it, down by your belly button, but actually up where it can make a difference. And then you move to the body worn mics, which of course, give that more consistent sound, with the head worn mic kind of being the preferred option there.
Right. And then you get into table microphones, which are really what are the first choices for group miking if you've got people around a meeting table. The top one there is a surface or boundary microphone that sits on the table. They come in all sort of shapes and pickup patterns and so forth. The great thing about those is that they have a very low visual profile, so they don't stand out very much on the table, which is nice. The one risk is that it is possible to cover them up with something. You could set papers or a notebook on top of it. It sounds crazy, but it does happen. And if you think that that's a risk, the microphone below that, the gooseneck mic, is sometimes a better choice because it gets the microphone up off the table surface so it doesn't pick up as much noise from pencil tapping or paper shuffling. You really can't cover it up, and usually the goosenecks come in different lengths so that if you want a short one, that's fine. If you need a real tall one because the mic is going to be further back, you can get whatever option suits you. Then over on the far right there, we've got a couple of little bit more special purpose solutions. In the top, we've got the white square, which is an array microphone that fits in the ceiling. And we'll talk more about array microphones in a little bit. But ceiling microphone solutions are great when you can't put anything on the table or you don't want to put anything on the table. Many of you might have run into situations where, it's an executive boardroom, the table's made of imported Brazilian marble or something, and you can't drill any holes in it, or maybe you just don't want the visual intrusion of any microphones on the table. So an overhead mic can be a great solution in those cases. And then the one below that is something that's a little bit more specialized, sometimes called a conference system or a discussion system, which is actually an integrated all-in-one sound system. So you've got a gooseneck microphone, a loudspeaker, headphone jack, and in this case, even some control buttons that might allow voting or volume control or anything like that built into the system. So this is basically a sound system in a box. You put this on the table, and it handles all the sound reinforcement between all the people in the room so that each person speaks into their mic, everybody else hears from a speaker right in front of them. So if you can't put anything on the table or drill any speakers into the walls or into the ceiling, or if it's a temporary conference at a hotel or something like that, a discussion system makes a great alternative. So let's talk about a little bit about about wireless microphones. Most of those options come in both wired and wireless variations nowadays, and more people are picking wireless just because of the convenience and the mobility. Even if it's not a presenter who actually has to move around in the room, it is nice in some cases to be able to just take the microphones off the table, put them away when you're not using them. Maybe the room only gets used for meetings on certain days or something. With wireless, you don't have to drill any holes in the table. There are a lot of different spectrum options in both the UHF band as well as higher frequency ranges. So depending on where you're at in the world, some of those ranges might be more or less appealing to you, but there are plenty of opportunities to find some spectrum for those kinds of systems. Modern wireless mics, if you haven't used one lately, now offer very sophisticated rechargeable battery systems with charging docks so that you can just drop the microphone into a charging station when you're done using it, and then it's ready to go the next time. And you can even monitor the status of batteries and things like that remotely using software. So you can check on microphones even when you're not in the room. They do cost a little bit more, but for many people, the convenience is worth the extra premium. And you've kind of got two different flavors of these now. In the upper photo there with the conference table, you can see a little white, grayish white square on the wall. That's the what you might think of as the receiver antenna. That's the transceiver access point, and that's what picks up the signal from the mics. And of course, you can still get wireless mics in the traditional rack-mounted receiver style, which are a little bit more popular at events. But either one can work for meetings, depending on whether it's permanently installed or temporary or what. So definitely consider wireless.
When we're talking about wireless and the cost of wireless, it's worth mentioning too that the cost varies wildly. I mean, you can find wireless mics that, range in price from $200 to $300 up to $2,000 to $3,000 per microphone. And when you think about, what the differences might be there, or why is there such a range, there's a lot of features and things that go into it. But the most important thing to look at is something called channel density, which refers to how many microphones you can use in the same room at the same time, and how much spectrum that takes up. Spectrum is at a premium now. In the UHF television bands, there's going to be less of it in the future. So looking at those highly spectrally efficient wireless microphone systems is a valuable thing to do. And the question you have to ask yourself when you're thinking about buying a wireless system is, how many mics do I need? Because that's what drives up that cost. The more mics you want to use, the more expensive of a system you have to buy. You can't, cut corners on the wireless because you need more of them. It's actually the opposite. You have to spend more money if you're going to use more of them. So that's some of the differentiating factor there too. And the other thing to keep in mind about wireless too is it really only has one job. I mean, its only job, the only reason you're spending all that extra money is so you don't have to run a wire to the microphone position. I mean, it replaces a $25 microphone cable. But obviously, people like to do this and they do it all the time, but those are just some things to keep in mind.
Right. All right. Let's see. Let's talk about another big characteristic of microphone design is directionality, and this is one that a lot of people either have never heard of or are only vaguely aware of. There are multiple types of pickup patterns for microphones, or polar patterns as they're called. Omnidirectional is sort of the most basic, means it picks up in a 360-degree circle all around the microphone, which is great to pick up a group of people, except it tends to pick up a lot more room noise, reverberation, maybe even feedback from the sound system. So in most cases, you're going to want to be looking at a cardioid or supercardioid or even a bidirectional mic, all of which have progressively narrower pickup angles. So you see those figures there, coverage angle, 131 degrees, 115, 90 degrees. So for instance, a cardioid is wide enough that you might be able to pick up two people at a table with one mic. A bidirectional is better when you're really trying to focus on one particular person, maybe at the end of the table, and you don't want any pickup of the people next to them or the surrounding noise. Another characteristic or spec from microphones is the distance factor. And Gino, a lot of people are unfamiliar with this one. What does it mean?
So one of the, again, advantages that you see from the directional microphones is that they do a better job of rejecting unwanted, or at least sounds that are originating off axis from the front of the microphone. And what that buys you, again, is better signal to noise ratio, the desired signal versus the noise level in the room, right? What the distance factor allows you to see is kind of how much better of a job a directional microphone does of rejecting that unwanted noise that you're trying to pick up. Because the way you look at it here, the way to think about it is an omnidirectional microphone has a distance factor of 1, which could be a unit of measurement. Let's pick feet, for example. So what that's saying is that in a given room, if you place the omnidirectional microphone a foot from your mouth or from the talker's mouth, you'll get a sound signal to noise ratio, sound quality of X. A cardioid mic can then be placed 1.7 feet away and sound just as good being somewhat relative, but just as good as the omnidirectional microphone sounded at 1 foot away. And then the supercardioid will sound as good as an omnidirectional at 1 foot away when you put it 1.9 or almost 2 feet away, basically, right? So you use that distance factor to figure out how much further away you can put the microphone from the sound source and still have it sound the same, basically, because that is, again, one of the advantages of the directional mics is it does allow you to put them a little bit further away from the sound source. You can see that it's not, a night and day difference. It doesn't get astronomically better when you go to a directional microphone, but there is some advantage there. And again, it's all based on that reference of how far away can you put an Omni. You can put it X far away, then you can put the cardioid mic 1.7 times X far away and have it sound just as good. That brings into another concept, which is another sort of misconception about microphones, is that a directional microphone will somehow go out and reach out to the sound and bring it closer to you. People will ask, well, what's the reach of this microphone? Microphones don't have reach. They have something called sensitivity, which we'll talk about in a minute, but that's how sensitive it is to varying levels of sound. The more sensitive the microphone, the more sensitive the microphone, the better job it can do of picking up weaker sounds. But, the further away you put the microphone, the more it's going to pick up that room sound. And we have some further illustrations of this later on. But the distance factor, again, is a way you can look at that and help decide how far away you can put a microphone.
Now, something a little newer in the microphone area is array microphones, and the concept, the theory for these has been around for decades and decades, but they've only really become popular in the last few years or so. So an array microphone is actually a group of several or even many microphones arranged in a specific pattern and then all processed through some DSP to combine each microphone signal in different ways to sort of create a virtual microphone pickup pattern, which we call a lobe at Shure. And in the picture there, that one is the MXA 910 ceiling array mic, which can put out 8 different lobes at the same time. And the reason that it's actually very useful is because you can electronically aim those lobes wherever you want. So if you've got those seats around a table, you can point a lobe at each of the seats or every 2 seats or whatever works out. And you can electronically change the width of the lobes. So you can define whether you want a really tight pattern on one seat or whether you want a wider pattern that picks up 2 or 3 people, whatever makes sense for that room. But the nice thing is it doesn't require any physical repositioning of the microphone or physical adjustments. It's just all done electronically.
And in addition to the repositioning, the other advantage of having an array microphone is, again, depending on the processing that's behind it, is you can make these multiple elements work together in a way that you can create extremely directional pickup patterns, much more directional than you can with like a single or dual element microphone like most, handhelds or head-worns are, or something like that. So by using the kind of DSP horsepower, you can create microphones that have as narrow as like a 45 or 50 degree pickup angle instead of like the 126 degrees of a cardioid pattern microphone. And again, that's all done electronically, but that allows some array microphones like Shure MXA 910, for example, pictured on the left here, to have a distance factor of as much as 4, right? So if you want to really get into putting a microphone further away, which of course, if you put a microphone in the ceiling, of course it's going to be further away. The further away the mic's going to be, then the more important that high directionality becomes. And that's another, again, advantage of the array microphone, is in addition to being able to move the patterns around, you can create this really, really highly directional pattern.
Right. Standard microphones don't really work very well in the ceiling unless the room is basically a recording studio.
Right.
But an array microphone can work very well even in what we would call an average room.
Yeah. I'm just going to interject something here because somebody had typed in a question, which I know we normally take them at the end, but I think it's maybe worth bringing up. Someone asked, are we talking about dynamic microphones here? And that was a topic that we kind of opted to leave out of the presentation, which is the way a microphone takes sound waves and changes it into electrical energy. There's dynamic and condenser and ribbon and all these other kinds of microphones, but the principles we're talking about here apply no matter what the transducer type is.
Right.
So the directionality, the distance factor, the physical design of it, all of that could apply to a dynamic or a condenser microphone. And there are some pros and cons to each. A lot of what we end up talking about here, particularly in these sort of AV conferencing applications, are condenser microphones.
Right.
Because they're more sensitive, which is needed since the microphone ends up being further away from the sound source, so you need that additional sensitivity. And condenser microphones can be made much smaller as well. So if you look at, especially again, the ear-worn or lavalier mics or even the little gooseneck mics, they're very tiny, and that's something that you can only really achieve and have it still sound good with a condenser microphone. But the concepts here could apply to dynamic or condenser.
Right. All right, and then let's talk about electrical output because this is something that has actually changed going in the transition from analog to digital. Analog microphones have a characteristic output level. There's a certain amount of voltage that comes out given a certain acoustic volume going in. And there's also a different wiring configuration. You can have balanced output, unbalanced output, which influences how resistant the signal is to electronic interference going through the cable. Then every microphone has an impedance to its output, which is not really important by itself, except it becomes important when you start trying to connect it to some other device downstream, which also has an impedance. The nice thing is, as we transition into digital audio, those are much more standardized connections as far as signal level go and impedance and so forth. So there's not as much to worry about there when you're connecting things together. You typically find microphones or audio equipment either with USB output or something called Dante, which we'll talk about in a minute, which is a digital audio networking protocol that runs over Ethernet. So you'll find microphones with USBs, microphones with XLRs, and everything in between. But the big ones for professional use are the XLR and analog, and then USB and Ethernet connectors for the digital. If you have to change from one format to the other, that's no big deal. There are boxes available that convert one mic signal into a USB to go into your laptop. We're using one of them here. Or larger boxes that connect multiple microphone signals into a single Dante feed to get onto a network. But there's all kinds of variations of those boxes, whether it's one mic or 16 or more, depending on what you're trying to do.
So speaking of digital audio now, moving from the analog to the digital domain, just very quickly here, let's kind of explain what the difference is. And really what you're doing, not to be overly obvious, but you're digitizing your audio signal, right? Which means you're changing it just like anything else that you make digital is you're converting it to a series of ones and zeros that represents the original audio signal. So what's shown in the red line here would be an example of an analog waveform that has some amplitude associated with it or level, which is as the peaks go up and down, that refers to the amplitude of the signal, and some frequency as well, right? There's a frequency component to an audio signal. And in digital audio, what you do is rather than having a continuous analog waveform, right, a varying voltage that is directly analogous to the original sound wave that was converted to the varying voltage. With digital audio, you now have to sample that analog waveform. So that's kind of what the blue dots are representing here, is at various points in time, you grab a snapshot of the level and frequency that is currently happening with your audio signal. In the case of CD quality audio, that's 44,100 times, or 44.1 kilohertz per second, right? That's how often the waveform is sampled for what we consider CD quality audio. And then each one of those snapshots has a certain bit depth associated with it, right? So it's a 16-bit signal. So that's 16 either ones or zeros that happen at each one of those little blue points in space. A lot of more professional audio equipment now uses a 24-bit 48 kilohertz signal as far as bit depth and frequency, sampling frequency goes. But that's essentially what you're doing. So you're creating this digital representation of the audio signal that is now data. And once it's data, you can do all kinds of other things like you might do with data. One of the main ways it's utilized now is in something that's referred to as networked digital audio, or sometimes called audio over IP or audio over Ethernet. But it's a networked protocol that allows you to essentially multiplex many channels of audio onto a single Cat5 cable, for example. So just by way of comparison here, if you had 8 channels of wireless microphone signals coming off of 2 receivers here that you needed to connect to an audio mixer, and you were doing it all analog, you have to run a mic cable from your receiver to your mixer for each of the mic signals. So we've got, actually, this would be 8 cables making the cable spaghetti here to get between the receivers and the mixer, right? Which is fine, it works, but it's a lot of cabling, a lot of copper. You can often do it more easily by using off-the-shelf Ethernet hardware if you have a sort of standard audio over IP protocol. Dante is an example of one. That's kind of the protocol that Shure and many other pro audio manufacturers have adopted now, that allows you to put your audio signal onto an IT network. So in this case, now we've just got a standard, just happens to be a D-Link switch, could be anything, but that's just the photo that we grabbed there is of a D-Link switch. And you've got an Ethernet cable running from the Ethernet jacks on each one of these receivers to the switch. You connect your audio mixer to the switch, and voila, 8 channels of audio all running on essentially just an Ethernet network. So it's less cabling, and it's less resistant to hum, buzz, all those other extraneous noises that can kind of bedevil an analog microphone signal or analog audio signal period become non-existent when you've got it on a network. And now that's all you're worried about is things like packet loss, whatever. And as long as your network is robust enough, you don't lose packets and don't need to worry about too much error correction, and everything sounds good. So it actually it can sometimes solve a lot of problem. And again, this is all using standard Ethernet hardware. Here's another example, same thing. Those MXA310 table array microphones actually have 4 mic signals that up to 4 mic signals that can be generated per device. So again, if that were an analog device, there'd be 4 mic cables coming off of each one of those pods. So you'd have 8 mic cables running into a mixer of some sort that had 8 analog mic inputs on it. Instead, we're able to connect those two to a standard Ethernet switch with Ethernet cable, and then our P300 audio processor, which is a Dante-enabled processor, is also on that network. And then we can either go USB to a computer for like a Skype for Business call using these microphones, or analog out to a Cisco codec video conference system there. The options are kind of limitless, but again, it vastly reduces the amount of cabling you need, and again, allows you to run on a standard IT network. It doesn't need to be standalone. So again, Dante just refers to a protocol. Dante is an audio over IP protocol. It's actually developed by a company called Audinate. They're the manufacturers of Dante, if you want to think of it that way. And that technology is finding a way into lots of different products, which makes it easy when you're connecting audio from one Dante-enabled product to another Dante-enabled product. Actually allows over 1,000 bidirectional channels of uncompressed digital audio, 24-bit, 48 gigahertz. 48 kilohertz audio if you're running on a gigabit switch. It's a very low latency. It's more or less plug and play, assuming your network is running the way it's supposed to. And it can even run on shared networks. And this is a real advantage to Dante over some of the prior network digital audio protocols that required their own standalone network that had to be completely separate. Even though it was using kind of standardized Ethernet hardware, it had to be its own thing. Dante can exist on your corporate network and doesn't interfere with your web browsing or your email or any of that other kind of stuff. It actually is a really good solution for that reason. There are a few considerations to keep in mind, but nothing terribly out of the ordinary. We typically recommend gigabit switches for a Dante network. Managed switches are a good idea as well, simply because there are some features that might cause headaches for a Dante network if you don't disable them, like, for example, green or energy efficient Ethernet. If that is enabled on your network switch, we recommend turning it off so that it doesn't turn off ports that you might need for your audio. And then again, on an unmanaged switch, you would be stuck with that. So managed switches are a good idea. Power over Ethernet can be helpful, since a lot of these Dante devices, many of Shure's devices included, require power over Ethernet in order to operate. Shielded cable is just kind of a good best practice for these. Be aware that many of these devices might have multiple IP addresses. So as you start putting audio equipment on your network, make sure that you have enough IP addresses available to support all of these devices. The last point there mentions that Dante flows are unicast by default. Let's talk a little bit more about that, actually. Again, if you're attending this webinar and you're from the IT background, you know what unicast is, right? It's a one-to-one connection. And it's used for the majority of audio data that's sent between devices on a Dante network. And the reason this is important is because we get a lot of questions from people that are scared of putting Dante on their network. They have this conception that if I have a Dante device on my network, it's going to flood my network. It's going to, cause a bunch of latency or packets getting lost. It's just going to cause havoc, right? But it doesn't do that, because just having a Dante device on your network in and of itself doesn't really do anything. And once you make a Dante connection, unicast, goes from one point to the other point, and that's it. It doesn't just blast out there on the network and take over everything. The flow only gets made between the two devices that need it. And again, that's how Dante works by default. Now, there is a little bit of multicast to a Dante network. Again, that's a one-to-many connection, right? It's used by Dante for clock sync and discovery, right? So in a digital audio network, devices have to stay synchronized to a common clock so that the data packets stay in sync and everything. So it's important that they share a common clock, and that's multicast is used for that clock data, and also for discovery. So when a Dante device shows up on a network, it squibs out a little bit of data just saying I'm here in case anybody needs to know that I'm here, and that's really about all that it's doing there. You can set up your Dante flows to be multicast instead of unicast, which is more efficient if you do have a single Dante source that needs to reach multiple destinations. Rather than having to set up multiple unicast flows, you could set up one multicast flow and allow as many devices as you need to pick that signal up. But again, that's only if you need to. But it's important to know that that little bit of multicast is required for clock sync and discovery, because if your network does block multicast, that can cause problems for a Dante network. So you want to make sure that's allowed if at all possible. Just to put some numbers behind the bandwidth here so we know what we're talking about. A general rule of thumb with Dante is for 48 kilohertz 24-bit signal, 4 channels of Dante uses approximately 6 megabits per second, which isn't much. So that means 64 Dante channels is about 96 megabits per second, which is 9.6% of a gigabit link. That's not a whole lot. And the typical conference room isn't really even using that many stuff. Most AV conference applications might have maybe 16 channels of Dante running, which is not a lot. That's 2.4% of a gigabit link. So the bandwidth usage is very slow. So if there's ever any hesitancy to put Dante on your network because of, oh my God, all the traffic and oh, it's going to be a nightmare, it really is kind of insignificant for the most part. And again, you can make use of multicast if you have these one-to-many connections. Back to the world of analog.
So back to the world of analog, because all that digital stuff scares me. We've got our source sitting in the room and saying something, and they, as an average talker, they've got a characteristic output level of about 74 decibels of sound pressure level at 1 foot. The key thing to know is that that drops along with distance, and it drops logarithmically. So for every time you double the distance from the talker, you get a 6 dB drop in the signal level. So if you start out at 74, at 2 feet, you're at 68. At 4 feet, you're at 62. And at 8 feet, you're at 56. After that, it starts to flatten out, and you have to go quite far away to have really significant drops beyond that.
I'll just interject for those of you who are maybe not familiar with the decibel and how it kind of relates to human hearing. A 10 dB drop in level is what most people perceive as being half as loud. So that means somewhere between 1 foot to 2 foot, almost to 2 foot, which would be 12 dB. That's like half as loud, and you can experience that yourself when you have a handheld microphone. Hold it 2 inches from your mouth, and then move it to 8 inches from your mouth, and hear how dramatic of a difference that is, how much you lose just by doing that.
Right. And of course, there's also a room, because we're not having meetings outside anymore like we did in school. So the room also plays a part here and generates some background noise and some reverberation caused by reflective surfaces in the room. And those tend to stay the same throughout the room. They're fairly consistent. So that means that essentially the talker is kind of sitting in this swamp of noise and reverberation. And depending on how deep that swamp is, that impacts whether or not we'll be able to hear the talker at a certain distance away. The farther we are away, the more we get close to that, sinking into that swamp of noise and reverberation. Now, of course, we got to add a microphone to all of this. So if we put the microphone 8 feet away, you can see there that the microphone level that it's picking up is barely anything above the noise and reverberation level. So it's not going to sound very intelligible at all. Ideally, we want a speech-to-noise ratio of 20 decibels or more. And to do that, we most often have to move the microphone closer. That's why, as a rule of thumb, if we don't know anything about anything, we'll typically tell people, put the microphone within arm's reach of somebody, and you'll probably be okay, unless you're in some weird situation. Now, can you go farther than that? Absolutely, but then you got to start considering what are the conditions like. Now, of course, we also have to think about the fact that usually you can't get by with just one microphone. You probably have several, and every time you add more open microphones, you're picking up more noise, because Each microphone picks up some of its own noise, but it's not really adding anything to the voice pickup. So it's just like you are raising the noise floor even higher in the room, which makes things worse. And again, it's logarithmic, so each time you double the number of open mics, you get 3 dB more noise, which means if you've got 8 open microphones, now you've got 9 decibels more noise than you had with one mic. And if you're running a sound system at the same time, you'll be getting closer and closer to the point of feedback. So if we learn one thing today, it's that you've got to control the number of open microphones, whether it's by people pushing a button when they want to talk or having a device like an automatic mixer do that for you.
So what you're saying is go ahead and buy as many microphones as you want, just don't turn them all on at the same time.
Exactly, right, yes. In fact, buy as many as you need, plus a couple as spares.
spares,
Want to have
sure,
extras,
yeah.
yep, or to give as gifts. So typical applications. The big two in the meeting room context are sound reinforcement and AV conferencing. Sound reinforcement means that you're amplifying the microphone signal to be heard in the same room. And that means feedback is a consideration like we talked about. And this is a one-way process so that you're generally amplifying the sound in one direction to listeners. The listeners aren't always talking back. In AV conferencing, now you're taking the microphone pickup, transmitting it to another site, and it's amplified for listeners there. That's a two-way process, though, because those people are usually able to talk back with their own microphones. The other applications you see are recording and streaming, but those are actually a little bit different and don't typically cause too many problems because it's a one-way process. It's kind of a closed circuit. There's not a whole lot that can go wrong as long as the signal can actually get to the recorder or get to the destination. In sound reinforcement, though, there's actually a few different formats. When we talk about standard sound reinforcement involves a one-to-many type of process. One talker with many listeners. You got a presenter up at the front of the room or somebody at the head of the table. Everybody else is listening. Increasingly, though, in a business context, you've got many-to-many sound reinforcement where everybody around the table or everybody in the room is both a talker and a listener. And this complicates things a little bit because now you don't just have 1 or 2 microphones up front and then a bunch of loudspeakers in the room. Now you've got a microphone for everybody because they all have to be able to talk equally well. And you've got to have loudspeakers near everybody so that everybody can hear. This gets to be a little bit more difficult because you run into issues with feedback or echo in conferencing situations, and those discussion and conferencing systems can be great for this because everybody gets their own personal microphone and loudspeaker. So the feedback problem is solved, the echo problem is largely minimized, and everybody hears consistently in the room, whether it's 10 people or 1,000 people. Just to look at it another way, a single zone sound reinforcement system, we plug 1 or 2 mics into the system and all the microphones come out of all the loudspeakers. That's fine as long as you don't run into a situation where the sound from one of those speakers gets into one of those microphones at too high of a level. Because when that happens, the system starts to oscillate, which causes feedback, which is perceived as either a ringing or howling or whistling or something like that, depending on the conditions. And there are ways that you can get around that and decrease it. If you don't have enough gain before feedback, there are a handful of tried and true methods. You can either move the microphone closer to the talker or the speaker closer to the listener, because then you don't have to turn everything up so much, and that reduces feedback. You can reduce the number of open mics, like we talked about. You can move the loudspeaker farther away from the microphone if you want to. That always helps too. Using directional microphones and loudspeakers helps, but it's not like a night and day difference. It's usually something you're probably doing already anyway. In the electronic realm, you can use equalizers or a digital feedback reducer to automatically detect and equalize out the feedback by inserting small notch filters in the system. And if you're wondering, well, how do I know if I need to do any of these things? We've actually got a calculator online called PAG-NAG, and PAG stands for Potential Acoustic Gain, and NAG stands for Needed Acoustic Gain. So you basically, well, we'll bring it online, we'll show you, but this is a way of actually predicting a good estimation of whether or not you're going to be able to get enough gain before feedback from the sound system.
Here we go. So again, this is you can follow that link from the Shure website to get here. But again, by putting in known distances, you can actually predict whether or not your sound system is going to generate enough level before it gets into feedback. So if you're sitting there looking at all that list of do's and don'ts and things to make it better, there's some things you can do just from a setup perspective ahead of time to kind of make sure you don't get into that situation. So this tool allows you to choose a couple different things, including microphone type. You know, if I choose boundary, it goes like that, right? But you can choose hanging mics, you can choose gooseneck mics. So we'll go with goosenecks. That's pretty common, right? And then here is the factors. Number one, the number of open microphones. As Chris mentioned earlier, right? The more mics you have, the more likely you are to have feedback. And there's a little kind of sub thing under here that says, are you using an automatic mixer? Now, we'll talk more about those in a minute, but one of the advantages of using an automatic mixer is it essentially keeps the number of open microphones to one, right? Which is useful. So, so that's kind of a cool thing there.
And we should just clarify, it doesn't limit the number of talkers to one.
No.
But as additional microphones are turned on because different people are talking, it adjusts their level just slightly so that effectively, acoustically, the impact is the same as if it was one.
So here we put in the talker to farthest listener. So that's we kind of picked the person furthest away and said, how far away is that person? How far away is the microphone from the loudspeaker? I don't know. It's probably about 6 feet there. Mm-hmm. And how far away is the farthest listener from his closest loudspeaker? And that's probably about 6 feet or so. And then the talker to the nearest listener. Now that's for our needed acoustic gain. What we're trying to achieve here is so that the person that's sitting furthest away hears at the same level as the person that's sitting closest. So if you put in, say a person's 2 feet away, and then talker to microphone, as we mentioned, that's important, right? So if the talker to microphone distance is probably about 3 feet there, what do we say here? Well, we're saying we need 26 dB of gain. We're only getting 16 and a half. So that means this system will suffer from feedback. Now, what can we do here? Well, let's see. We can probably move the microphone further from the loudspeaker, possibly. That got us closer. Still not there. We can move the microphone closer to the talker.
No, you went the wrong direction with that.
Oh, I put in microphone to loudspeaker. Right, I wanted to make that 10 feet.
Yeah,
there we go. And now we probably could even put the talker further away from the microphone, and that's still not quite. So we still got to be a little closer there. 2 feet, not quite. So we changed the distances there to get it to the point where now we know the sound system can operate without feedback. So play around with that if you get a chance on the Shure website, but it is a way to kind of figure out, again, how to get away from those feedback issues. As Chris mentioned earlier, we were talking about the single zone sound system where all microphones feed all loudspeakers, but another way to combat this problem is to do what's called a mix minus or zoned loudspeaker system, where now the microphone in front of my mouth is feeding the loudspeaker that's over the talker on the other side of the room and not the one over my head, which kind of makes sense because I don't need to hear myself being reinforced through the loudspeaker. I just need to hear the guy that's sitting on the other side of the room. And by doing this, now we've made that distance from the microphone to the loudspeaker much, much greater. And that, again, is going to allow us to get better gain before feedback. So you see this often applied in conference rooms.
Now, if we're talking about, instead of amplifying within one room, having multi-sites like video conferencing, now we've got a slightly different problem because the sound from our microphone or microphones goes through the transmission network, comes out in another room out of their loudspeaker, and it might get picked up by their microphones, either because the mic is too close to the speaker or it's turned up too loud, or the room is reflective and the sound is bouncing off the walls and into the microphone. Can happen for a lot of reasons, but then the audio gets transmitted back to us and comes out of our speaker. Because there is a time delay in that transmission, we hear it as an echo instead of as feedback. And there's really only one real good solution to this, which is that we need to use an acoustic echo canceller, which prevents the sound coming out of the loudspeaker from being retransmitted through the microphone. It gets removed electronically. The tricky thing here that a lot of people forget is that an echo canceller is something you use to prevent sending echo to other people that they will hear. So if you're hearing echo, it means the other guy needs an echo canceller. There's really nothing you can do to prevent them from sending echo back to you. And it may be a moot point if the person on the far end is, holding a phone or using, a headset or something like that. There's no acoustic connection between the earphone and the microphone. There's no bleed there. But as soon as you talk about a meeting room with speakers and microphones that can potentially pick up each other, then you have the likelihood of echo happening.
An acoustic echo canceller is more or less required in any sort of AV conferencing system like this to prevent that from happening.
Right. And in fact, as you get into more complex systems in larger rooms, you often find that when you have multiple microphones and multiple loudspeakers, the echo relationship between them is all slightly different, which means that you might not be able to expect a single echo canceller to handle all the different acoustic solutions there and keep up with it. So it generally is better when you have more microphones to have individual echo canceller paths or channels for each microphone, or at least each section of microphones perhaps. So what is the box that does that? Well, nowadays it used to be mixers and different boxes and everything all racked together. Now it's basically all one big box. Well, it's not even big, is it?
It's a small box.
One small box.
With a lot of DSP horsepower.
Right. And still only 120 volts. How did we do that? And it's got everything in it. Mixing, whether it's manual mixing or automatic mixing, problem solvers like automatic gain control, echo cancellation, electronic noise reduction, maybe feedback reduction, as well as some stuff to just, polish the sound or change it to your liking, like equalization or maybe dynamics control or something. But it's typically an all-in-one box now, and these come in, a variety of sizes to handle more or fewer microphone channels. The automatic mixer, if you haven't used one before, it keeps unused microphones turned off, or at least turned down, and then automatically activates the microphones when they're needed. And this happens so quickly that you don't chop off the beginning of a word or anything like that. It's basically transparent. And by doing this, you improve intelligibility because you get rid of all that extra background noise and reverberation. And it also means that the sound is more natural because you're not picking up one voice with 3 or 4 microphones at different distances, which results in a wacky frequency response pattern called comb filtering like that, which is still usually intelligible but tends to sound kind of like you're in a tin can. So we don't usually like that sound.
Yeah, I would say that anytime you have an application where there's more than 2 microphones, you should be using an automatic mixer.
Yeah.
So people ask, well, how many microphones do I need? What if I only have 2 or 3? It's like, yeah, really any speech application, it's worth having one of these in there. And again, they're seamless. You don't miss words. I mean, if it's a good auto mixer, which most of them are pretty good these days, you don't miss words. And if again, you don't even realize it's doing anything until someone would turn it off, and then suddenly you'd have 8 live microphones, and you'd be like, well, what's going on here? And as Chris said, there used to be standalone boxes that were automatic mixers, but that's kind of a module that is just part of a suite of signal processing in most of these black box DSPs now.
Yep. We've got a number of online resources that you can peruse if you want more information, like a printed book, downloadable called Audio Systems Guide for Meetings and Conferences. We've got an extensive FAQ section online that's got all kinds of good questions about feedback and echo and microphone placement and whatnot. And if none of that works, as a very last resort, we've got human beings, which you can call and actually speak to. And you don't even have to throw food to them or anything. So you can call our product support area or email us at support@shure.com, and they'll be happy to explain things in more detail or help you make a decision on what you need or anything like that. And then, of course, we've got lots of webinars archived, right, Cheryl?
Oh, yes, we do. Speaking of, gain before feedback, we had an entire webinar just on that subject. So if it's something you want to dig more into, you can go to shure.com/training. There's a ton of other great webinars there, so check them out.
Now, do people have any questions that we can answer right now, though, without a phone call?
Oh, yes, they do. Question number 1. In an array microphone, does the size of the lobes affect the directionality and or sound quality of the MXA 910?
Well, that's a very 910 specific question. I think maybe what being asked then is there are 3 different lobe widths you can choose in an MXA 910, wide, narrow, medium, of course. And no, that doesn't affect the sound quality. Nothing about the microphone sound quality or operation changes. It just gives you the option of covering larger or smaller areas per lobe.
Okay, and another MXA 910 question. If the best practice is to put the microphone at arm's length, then how can an MXA 910 ceiling array provide good audio quality?
Well, that goes back to that distance factor again. So when Chris said that about arm's length, he was referring to normal microphones that have like a cardioid or supercardioid pickup pattern, which again are certainly more directional than an omnidirectional microphone, but again, coming back to that distance factor, right? Even on a supercardioid, that's a distance factor of 1.9, right? So, if you can put again an omni mic a foot away, you can put the supercardioid 1.9 almost 2 feet away and get the similar sound quality. The MXA 910 has a distance factor of about 4, so that means you can put it 4 times the omnidirectional distance away and it sounds good. And in most well-designed conference rooms, an omni mic would sound okay at about 2 feet away, right? So if you put an MXA 910 in an 8 or 9 foot ceiling, it's right about where it would need to be to give you that equivalent sound quality as a standard microphone at arm's length. So it's all about that high level of directionality and extremely narrow pickup lobes that give you that ability to put it that far away. And that's why you can't take a typical cardioid whatever microphone and just hang it from the ceiling and expect it to work, because it just picks up too much room noise.
Okay. On your router, do you need one channel per mic on the switch? Like for 16 mics, does that mean you need a 16-port switch?
No. Well, I guess it would if each microphone was an individual Dante-enabled device. But when we talk about our wired microphones, those are still kind of an analog device. But what we're talking about here, like the MXA 910, for example, which has up to 8 lobes, which you could think of as like 8 microphones, those are all combined together onto that single piece of Cat 5 cable, right? So no, you don't necessarily need that, but of course that could vary depending on the design of the microphone.
If you had a room with 2 MXA 910s, you'd want 2 ports on your
You'd want
switch.
2 ports, right?
Yeah.
Because it's kind of a per device rather than a per microphone channel thing.
Okay. Can you use QoS on a Dante device?
Yes, in fact, that's another. So QoS stands for quality of service, and that actually is another reason to use a managed switch on the Dante network that supports QoS if you wanted to go in and make adjustments. In fact, on Audinate's website, they have some white papers or FAQs on how to properly set QoS for a Dante network. Again, it's not required, but if you have a lot of network traffic and want to go in and tweak that, you can.
Okay. This next person comments, I wouldn't recommend using Dante devices on your corporate network without testing in an isolated environment. Do you have any comments about that?
Well, I mean, like anything else you're going to add to your network, right? I mean, I suppose any IT person worth their salt isn't just going to let some bunch of rogue devices show up on their network without evaluating it first, right, and seeing what it's doing to you. So, I mean, as a general best practice, I mean, I would certainly support that. But in fact, maybe I would even encourage that, because you might find that, oh, yeah, this isn't going to be such a problem. We hear a lot of like, what? Not on my network when it comes to a Dante device, without even really trying it and seeing what happens. So in that regard, yeah, not a bad idea.
Okay. Is feedback an issue in a purely digital system?
Yeah, digital or analog, it doesn't matter, because the feedback occurs, again, it's a loop. When the microphone hears the sound coming out of the loudspeaker, you can get feedback. Analog, digital, doesn't matter. It's an
The
acoustic.
microphone doesn't care if it was analog or a digital signal that got to the loudspeaker.
No, it's purely an acoustic phenomenon.
Mm-hmm. All right. Any ideas of materials to learn more about Dante and practical applications?
Again, the Audinate website is a great resource for Dante. They have a list of, again, a great FAQ.
They have some of their own webinars too,
They
right?
have some of their own webinars. They have a great YouTube channel. You can learn a whole lot about it from visiting their website. In fact, we did a webinar about Dante specifically a couple years ago now, so it might be slightly outdated, but that does show some applications, talks about what Shure devices support Dante, which has probably grown since then, but that's another reason to look at the webinar archive.
Okay. Are there switches recommended by Shure for use with Dante? I've seen several instances with very cheap switches in place where switching black backplane throughout may have been an impact to the network performance.
So I'll put it this way, right? If you're gonna say you're looking at the Shure Microflex wireless system, which runs on a Dante backbone, and an 8-channel system is going to run you, around, let's say, $16,000 or something like that, right, for an 8-channel Microflex wireless system, and you need a network switch to kind of hold that all together and make sure it works. Do you really want to run down the street and Best Buy and get the $99 special? Right? Does that seem like a good idea? It's kind of like buying a Porsche and getting the cheapest tires you can from Pep Boys. Like, it's probably not the wise decision. So yes, not all network switches are created equal. I think that most people on the webinar would understand that. And as far as which one specifically to recommend, we don't really get into that because there are a lot that that are okay. It's probably better to keep a list of ones that don't. In fact, on Audinate's website, they actually have a list of blacklisted network switches that they don't recommend. So if you want to see which ones are definitely bad, go there. We always have good luck with the name brand. Cisco, like the SG series, are pretty rock solid for the most part. Those always work, but managed gigabit, PoE, QoS, no energy efficient Ethernet, that's pretty much the way to go.
Okay. Is there a digital or electronic way to compensate for proximity effect of a directional mic?
Ooh, that's a good question. I've heard that discussed over the years, but I don't know of anybody who implements
Well,
that.
it would have to be some sort of adaptive processing, because proximity effect, which again, for those of you who don't know, is a boost in low frequency response as you get closer to a directional microphone, or a thinning out or loss of low frequencies as you move further away. And so that means that as the distance is going to vary, the processor would have to be adaptive, in other words, to be able to sense that proximity effect is occurring and insert low frequency cut to compensate for that. You could do it yourself by just arbitrarily cutting low frequencies, right, to compensate for that. But then as the person backs further away from the microphone, the sound's going to really thin out because now you've cut the low frequencies. So good question, but I don't think the technology's quite got there yet.
Or you could just get a KSM-8.
Well, yeah, a low proximity effect microphone with a dual diaphragm like the ones we're using, the KSM-8s. That's a dynamic microphone in a handheld format, though, so not ideal for most meeting
It's not really
scenarios,
a meeting microphone, no.
Yeah, but boy, if you've got users getting too close to the microphone, we'd love to have some more of those. 'Cause normally,
Exactly.
Normally it's the reverse
Normally
problem.
they're sitting way back here and going, how come nobody can hear me? So.
All right. Hey, will you guys come out with an MXA series but wireless?
Ooh,
Really? Maybe.
That's an interesting question. Yeah, and I think that falls into the category of, it's sitting on the table. So one side of the equation is, well, why do you need it to be wireless? It's just sitting there. But there's always some reason why it turns out to be a little more convenient for it to be wireless. So
Especially for rooms with flexible configuration.
Yeah.
You don't have to even run that Cat 5 cable out there if it's
Right.
wireless. So
possibly.
I wouldn't hold my breath for a 910 though.
No.
But yeah, as I'll give the old PR response. As a private company, we don't really talk about what we're working on, but we are always working on stuff. I think if you look at our introductions over the past couple of years, you'll realize that we are always looking to innovate across all of the verticals that we sell to. So definitely. All right, I have a ton more questions here, but we just do not have the time. So I'm going to wrap it up with one more. But I'm going to say, if I didn't get to your question and it's just burning a hole into your brain, or if you have another question that comes into your head, please feel free to send an email to support@shure.com. We've got a great team of applications engineers that can answer just about every question, any question you could throw at them. And if you throw a question that they can't answer, they'll be excited to find out what the answer is. So support@shure.com. Send any of your questions there. So the last question I'm going to end on is kind of a self-serving one because it starts with a compliment to us. Not surprisingly, your audio is excellent. How are you configured for this audio conference?
Well, that's a good question. So we've got 3 KSM-8 dynamic handheld mics on little tripod stands here that we set up on this table because we don't use this room all the time for this. And those mics are feeding into an SCM820 automatic mixer. So that's activating the mics as they are needed and making sure they sound consistent. Output of the mixer is going into a little gadget called the MVI, which is part of our Motive line, which takes the mic level output of the mixer and adapts it to USB and plugs into my laptop here, and that's connected to our corporate network to connect to the webinar. So basically 3 mics, automatic mixer, USB interface, and away it goes.
Awesome. All right. We want to thank you so much for joining us today. We hope you learned something. I know I sure did. And like I said, go to shure.com/training to view any of our past archived webinars. This one will be available in the next couple of weeks. We want to thank you so much for joining us, and we hope to see you next time.